Hey there, this is Ankur, founder CEO at Lightscline. Let's learn something today about a problem we are facing in bringing AI to the physical world, specifically in the monitoring and controlling of assets across space, air, land, and sea. So on the left-hand side, you can see we are collecting huge amounts of raw data from different sensors deployed across wind turbines, assets in the sea, satellites, and so on. Each of these assets can have more than 20 sensors, and each sensor can be collecting more than 100,000 data points per second. And so we end up analyzing terabytes of raw data, which has to go away from the raw device, from the edge device, get transmitted, and so on. Now, ultimately, what we get from this is a decision advantage, or 5 Ws, which is what, when, why, where, and who. In order to go from the raw data to the 5 Ws, we, however, need to pass through the full infrastructure stack and a people-related stack of edge computing, bandwidth, compute and storage, and human capital. So let's look at these steps one by one. Now, the bottleneck with edge computing is that there is a maximum milliampere hour rating of power supply that can be put out, or a maximum wattage rating, because we cannot put large batteries, specifically in SWaP-C related scenarios. We cannot have large form factor compute and power resources on the edge. So that is a bottleneck. If we look at bandwidth, high cost is an issue. Intermittent connectivity, especially in air-gapped or remote environments, is an issue. And finally, Nelson's law of internet bandwidth states that the number of use cases always rises faster than the bandwidth. And so we'll always have a crunch here. In terms of cloud compute and storage, high AI training costs are increasingly becoming common as we store and train on large amounts of data. Finally, there's also a human capital cost involved in this because every hour of raw data collected is 40 plus hours of analysis. And so this does not scale well with the amount of data that we are collecting today. So given these four problems around edge computing and power, bandwidth, cloud computing and storage, and human capital, which is only rising very fast by the day, how can we solve these four problems to achieve better decision advantage? There are several ways to address this. We can have larger edge compute and storage servers. We can rely on the bandwidth improvements that are coming always. We can use more powerful cloud systems. However, what we can do is also take a step back and think from first principles and understand that the root of all these problems is more data that is being collected from the edge devices. Can we do something with that? We can ask, does more data mean more information? And can we train AI only to collect useful data from these sensors? This is precisely what Lightscline's innovation is letting us do. At Lightscline, we are leveraging AI to automatically identify the 10% important sensor data from large data streams, reducing 90% of the AI infrastructure and people-related time and costs. As you can see in this figure, Lightscline's data prioritization AI technology sits at the place of data generation itself. And now instead of collecting and processing and storing 100 gigabytes of raw data, which is a lot of infrastructure and people related time and cost, we're talking about only processing and passing and analyzing 1 gigabyte of useful data, which results in 100x efficiency improvements and speed improvements. This also enables applications that are currently unobtainable due to power, compute, storage, transmission, and latency bottlenecks. This helps us get to the 5 Ws much faster. We would love to know more about your problems, and we have also put in some resources on lightscline.com if this is of interest to you. Thanks for your time today.